In this lecture, we're going to look at three examples of some pairs of triangles and see how we can go about showing that these triangles are congruent to each other. So I want to show that these two triangles are congruent, and just looking at them, all I have information about are the angles. Now, just knowing the angles, even if you know all three of them, that's not enough to lock down the size of a triangle. And that's exactly what we're talking about here with this idea of similarity. Two triangles can have the same angles, but have different sides. So, um, what I'm lacking information about the sides, I'm thinking my only option is going to be that AA similarity theorem, but I don't have a pair of matching angles. I have one pair. Angle A and angle Z are congruent, but I need a second one. And angle B and angle Y aren't going to do it because obviously they're not the same, 23 versus 75 degrees. Well, but we can figure out the missing angles. Right? This angle here, angle C, has to be 180 degrees minus 82 degrees minus 23 degrees, because remember the angles in a triangle, their measures add up to 180. So if you do the arithmetic here, this angle is 75 degrees, and now we do have a match. Angle C and angle Y are congruent, and that's enough. We have two pair of congruent angles. So by the A similarity theorem, the two triangles are similar. And here's how we're going to write that. I'm going to write triangle ABC. And again, we want to match things up. So angle A and angle Z were corresponding. Angle C and angle Y were corresponding, and that leaves B and X. So the way I'll write that is I'll just put single wavy line. That's like the little wavy line that's on the top of the congruent symbol. So it's the congruent symbol, but without the equals part. All right, so how about these two? This is a little more interesting. The two triangles that I'm focusing on here are triangle A, B, D. That's the one that's enclosed in the other one. And the outer triangle, A, C, E. I want to show that these two are congruent. Excuse me, that they're similar. So to do that, I notice that they both have angle A in common. An angle is congruent to itself. Obviously, an angle has the same measure as itself. So I have the angle part. So again, now I'm thinking about the theorems that we have, right? And I have one that is side, angle, side. And I'm focusing on that one because I have information about the sides that make up that angle. So to use this theorem, I'm going to have to show that if I take the ratio of side AB and side AC, that equals the ratio of side AD to side AE. All right, well, let's put some numbers in here and see what happens. AB is 4. AC is 4 plus 2. AD is 6. AE is 6 plus 3. All right, 4 over 4 plus 2, this is 4, 6. This other side, 6 over 9. And both of these reduce to 2/3. And that's what I wanted to see. Right? Those pairs of sides are in the same proportion. So by the side angle side similarity theorem, these two triangles are similar. Okay, so I've got one more here. And it really is a very similar diagram, but we have different information. Now I know that BD and CE are parallel to each other. All right, so again, I don't have any information about the sides. So I'm really thinking I'm going to have to fall back on the angles and maybe use that AA theorem again. So what do I know about the angles? Well, because those two lines are parallel and side AC here is a transversal, I know that this angle and this angle are corresponding angles. And corresponding angles are congruent. We're going to look over at the other side. This bottom side here is also a transversal of those parallel lines. So again, these two angles, angle D and angle E, are also corresponding angles, which means they're congruent. And that's what I needed to show. I've got a pair of angles up here. Angle, I really shouldn't call it B, right? Because there's more than one angle that could mean. So let's do the full name here. Angle ABD is congruent to angle ACE. And looking down here at the bottom part, angle ADB is congruent to angle AEC, and there are my two pairs of congruent angles, right? That's what I needed to show. So by the AA similarity theorem, these two triangles are similar. And the way I'm going to write that, I'm going to say triangle ABD is similar to triangle ACE. And so that's the end of our discussion of similar triangles. In the next lecture, we're going to move on to the last triangle topic we're going to talk about, and that's going to be the Pythagorean theorem.